Hello everyone, welcome to my JEE Physics channel. So this question is given in 2024 JEE Advanced. So I felt something we can learn from this question. So that's why I picked up. Okay, so first go through the question. I think some might have already solved this question. So that's a good factor. Okay, if you're not solved and not done this question, you can definitely refer this question for center of mass frame application. So this question is purely related to center of mass frame, particularly second question. So let us see one by one. Okay, so first you go through it and solve the question and come back for the solution. Now in the question as given, see they have given different functions. See like there are two balls which are connected by a spring, and the third ball is coming with velocity u0, where u0 value is given a omega by 2. Okay, so then, and they have given that the position of the first particle has given something like this: x0 plus d plus a sin omega t. So this last function will tell you related to simple harmonic motion. Even second particle also position has given as something like an x0 minus d minus a sin omega by 2. So this will tell you, these two equation will tell you, first you need to understand this part. Okay, this is the spring and this is the first particle and second particle. They have given this is something like an x0 is the coordinate, then this will be what, let us say d. If d is the distance, then this particle will oscillate to and fro about this position by using the equation of what, a sin omega t. That means this particle will oscillate with the amplitude of a. Similarly, second particle position has given x0 minus d, that means d side left. Okay, I mean d distance left side. Okay, now this particle will oscillate within a sin omega t, that means with an amplitude of a. That means these two particles can oscillate with amplitude a about the positions given. This is x0 plus d position, this is x0 minus d position. So from these two positions, these two particles will oscillate continuously, okay, within simple harmonic motion. So this oscillating bodies, okay, are going to collide within third particle, or else there is a collision between the third particle and second particle, where second particle is oscillating in simple harmonic motion. So this is the first understanding towards the question. Okay, so they have given the finally particle 1 and 2 acquiring some center of mass speed and oscillate with amplitude b and the same angular frequency. Obviously angular frequency depends on k and mass value. Okay, so let us write down the omega value. I think all of you know, whenever two particles are oscillating, it's like a two body problem. We can convert it into single body problem by reduced mass. All right, so omega can be written as root of k by mu, where mu we call it as what, reduced mass. Okay, so m omega square will become the k. So reduced mass value we can write down that m1 m2 by m1 plus m2. So as particle mass is not changing, then omega value does not change even after collision also. So this is something like an extra point for this question. Okay, so let us see the first question. If collision is occurring at time is equal to 0, then what is the value of velocity of center of mass by a omega? Okay, so let us see at time is equal to 0, what are the positions? At time is equal to 0, what is the position of the first particle? x1 can be written as what, x0 plus d. Okay, so what is the position of the second particle? x0 minus d, because as time value if I am keeping 0, sin omega t will become 0. So these two terms get 0. I get only x0 plus d and x0 minus d. That means both the particles are at equilibrium. Okay, one confirmation is both the particles are at equilibrium of oscillation, and the same time let us go with the velocity of the first particle. Velocity of the first particle is nothing but dx1 by dt. So I want to see that in what manner the first particle is moving. At time is equal to 0, I am calculating. Okay, so dx1 by dt will give you what, a omega cos omega t. So at time is equal to 0, then v1 value will become plus a omega. So similarly v2 I can write down dx2 by dt. So if you derive it, x0 derivative, d derivative will be 0. Then this will be minus a omega cos omega t you will get. Okay, if you derive it. So I think at present no need to explain the derivative, I feel. Okay, then v2 value will be minus a omega at time is equal to 0. So at time is equal to 0, I can make conclusion from all these things. Okay, particles are at equilibrium. First particle is having the plus a omega velocity, second particle will have the minus a omega velocity. So this I want to draw, okay, here. Now this is the second particle and spring, and this is the first particle. Both are at equilibrium positions. One is x naught plus d and other one is x naught minus d. Now this is having the a omega forward and this is having the a omega backward, because second particle velocity we are getting negative. Okay. Next, if I am taking the third particle which is going to collide, it is having the velocity of u naught, which is equal to a omega by 2. Directly I am taking. Now they have given that the collision between these two particles is elastic. Elastic collision is given, and moreover both the particles are having the same mass. Even all the three particles are having the same mass. So same mass is the elastic collision. We know that the collision between similar particles, if it is elastic, the velocities get exchanged. So just after collision, what is the scenario? Just after collision, I can write down that. Okay. Now third particle velocity will be transferred to the second particle. So second particle will move with velocity a omega by 2, and first particle velocity does not change, remains a omega, and then third particle will get the velocity of second particle. That means third particle will go away with angular velocity, linear velocity a omega. So then we got the system with different velocities. Now if you see the particles which are connected to the spring, okay, so they will have different velocities. Now what is the velocity of center mass? It's a direct calculation by using the formula. Then m into a omega by 2 plus m into a omega, both are in the same direction, I am adding, so the total mass 2m. So will give us, this is 3a omega by 4. But what is the question they are asking? They are asking the v center mass by a omega they are asking, which is nothing but 3 by 4. So then you will get the answer of 0.75. Okay, this is the entire solving for the first question. Okay, this is the question. So this answer goes to be 0.75. Now let us come back to the second question. If collision occurs at time is equal to pi by 2 omega, so this is important, pi by 2 omega, then what is the value of, this is 4b square, this one typo error. Okay, 4b square by a square value they are asking, where b is the new amplitude. Okay, I will explain that part. So first of all, we will concentrate on the time. So this is the important thing. Okay, what is the time they are asking? Pi by 2 omega. Now I will write down pi by, I think some people understood this pi by 2 omega. I am explaining this for the people who are like unable to recognize this time. Okay, so in the place of omega I can write down 2 pi by t, then I will get t by 4. Okay, that means 1/4 of time period they are asking the scenario. So we know that at time is equal to 0. So already from the first question we know that at time is equal to 0, where are the particles? The particles of 1 and 2, okay, are at equilibrium. Okay, this is having the velocity a omega forward, this is having the velocity a omega in backward direction. So in after t by 4 time, means 1/4 of the time period, where this particle will go. So we know that if particle is in equilibrium in 1/4 of time period, it will go to the extreme position, right? Okay, so this also will go to the extreme position. So both will go to the extreme position in time of t by 4. Okay, so that means for the second question, where are the particles, or where are the first and second particles? Just a minute, let us erase this part. Yeah, now the first and second particle, let us say that this is the second particle, this is the first particle. Now what are the position of first and second particle? At what time I am calculating? At time is equal to pi by 2 omega. They are at extreme positions. Okay, that means the position of this one is x naught plus d plus a. This one is x naught plus d. Okay, sorry, x naught minus d. X naught d minus a. So this is the equilibrium, which is also natural length of spring. Now the spring is extended by a left side, even a right side. That means total extension in the spring. total extension in the spring is, okay, in the spring is this, you can take it as 2a. Then what is the initial energy of the system is half k into 2a whole square. This is the energy of the system, where kinetic energy of the system is 0 because the particles are at extreme position. At extreme position, we know that there will be no velocity for the particle. Okay. Now at this instant, the third particle is going to hit the second particle with velocity a omega by 2. Okay. If third particle is hitting, again collision is elastic, masses are identical, then velocities will get exchanged. So then after collision, what happens? After collision, the second particle will get the velocity of the third particle. So that means a omega by 2, and first particle remains at rest. This is just after collision. Okay. Just after collision this happens. Now see, this is moving and this is not moving. If you see individually, this will be obviously a little confusing one. That's why here we use the idea of center of mass frame concept. So then what is the center of mass frame concept? Let us see. First find out what is the velocity of center of mass for given situation, like this one, whichever we got it. So what is the velocity of center of mass? I can write down. So m into a omega by 2 plus m into 0 by total mass will be 2m. Then velocity of center mass will become a omega by 4. Okay. Now what is the meaning of center mass frame? Center mass frame meaning is, now you look at the things from the center mass. This is the second particle and this is the first particle. Now we are looking the things from the center mass, means observer is at center mass. Okay. If observer is at center mass, means observer velocity is a omega by 4. If he observing, then what is the velocity of second particle? See, actually second particle is having the a omega by 2 with respect to ground. Okay, so already one particle is moving with velocity a omega by 2 with respect to ground. Now I am moving, means center mass is moving a omega by 4. If I look from this, okay, this frame, then what is the velocity of the second particle? Obviously subtraction, relative velocity. Okay, so then its velocity will become a omega by 4. Now actually this is at rest. With respect to ground, first particle is at rest. Okay, first particle is at rest with respect to ground. Then if you see from the moving frame, any rest particle is seen from the moving frame, then that particle will appear opposite to the moving frame with the same velocity. That means if you see from the center of mass how the particles are moving, the particles are moving second and first. Even though I am writing more diagrams, it's not an issue for me, but ultimately you need to understand. That is my idea. Okay, so this will move with a omega by 4 and this will move with a omega by 4 in backward direction, and net momentum has to be 0 because center mass frame we call it as zero momentum frame. This is the other name given to the center mass. Zero momentum frame means if you look from the center mass frame, every particle momentum get cancelled out and ultimately net momentum has to be 0. Okay. So then at the same time, where are the particles? See, still we are talking about at a particular instant only, at time is equal to pi by 2 omega. They are at extreme positions. Okay. They are at extreme positions only. So that means somewhere here equilibrium is there. Now we need to identify the what is the amplitude, means this is not, see actually this distance is a, don't forget, this is the equilibrium. Okay, the particles came to rest or equilibrium at a distance a, amplitude a, but at amplitude means this is not the position with 0 velocity. Now this is having the some velocity. Previously this is the position of 0. See, this is the 0 velocity. Okay, here velocity is 0, that's why it's an extreme position. Okay, now the same position is having the some velocity. That means it's not the extreme. There will be somewhere extreme positions will be developed. That will be the what amplitude will be b. Okay, this will goes to amplitude b. Then how to solve this? So this is very easy. See, we are talking about, this is the extreme we are talking about in center mass frame. This is extreme and this is extreme in center mass frame. Velocity will be 0 in center mass frame. Okay, if you see from the center mass its velocity is 0, that means if you look at from the ground frame, then what is the scenario? If you look from the ground frame, they will have the velocity of how much? What is that? A omega by 4 forward, A omega by 4 forward. if you see from the center mass velocity is how much? A omega by 4. Then if you see from the center mass, this will appear at rest and this also will appear at rest. That means this is extreme, this is extreme. Hope you understood. Now the new amplitude is, let us say B and B. Obviously symmetry should be followed, center mass should not move. So then what is the total extension in the spring now? Total extension in the spring is, it's 2B. And previously what was the total extension? Is 2A. And we know the energy of the system. Okay. Now this is from the ground frame again. This is something like in a ground frame. At time is equal to pi by 2 omega. Okay. So now also we convert it into ground frame. This is the velocities from the ground frame. So now we need to identify the B value. So we can use the conservation of energy, right? So then what is the initial energy? I can write down half k into 2a square. So initial energy I am writing here, half k into 2a square should be equal to final kinetic energy. Final energy of the system. The energy stored in the spring will be half k into 2b square. Now b is the amplitude I am taking, plus kinetic energy is half m into a omega by 4 square multiplied with the 2. In this expression we forgot one energy. That energy is initial kinetic energy. See, actually this is the scenario just after collision, right? So this is the scenario just after collision, and this is the scenario when it is coming to the extreme positions. That means we need to conserve the energy between this part and this part. So here the extension in the spring is 2a. So I wrote the elastic energy stored in the spring. But along with that, second particle is having the some, what do you say, that velocity. So that kinetic energy also we need to add half m into a omega by 2 whole square. So hope you understood this part. Okay. So once you checked this particular situation just after collision and while they are achieving the extreme positions. So from this we can try and a and b values, or we can relate all the values. So you can cancel half and everywhere. So if you want, you can solve this mathematics on your own. Okay, by 4 plus this is half we cancelled out, 4k a square, which is equal to 4k b square. Half is gone out. Okay, this is m a square omega square by 16 into 2, it will be 8. Then 4k into, I can write down something like an, okay, b square minus a square is equal to m a square omega square. This is something like a 1 by 4 minus 1 by 8. Then 4k b square minus a square is equal to m a square omega square into, this is simply 1 by 8. Okay. Now we can replace the k value. Actually spring constant is not given in the question. So nowhere the spring constant has mentioned, but they have mentioned the same angular frequency. So luckily we have done this part. So we can write down the k value is equal to mu omega square. Mu value is m by 2 omega square is there. Okay. So k value is m by 2 omega square we can write down. So I can write down 4 times of m by 2 omega square is the k value. B square minus a square is equal to m a square omega square into 1 by 8. So the finally, okay, so to cancel out, m omega square also will cancel out. Then you will get b square minus a square is equal to, here omega square gone, m gone, then there is an a square term is there by it is 16. Okay, so 2 is there, don't forget this one. Okay, then it is 1 by 16. So I can write down b square is equal to a square plus a square by 16. So finally we'll get 17 a square by 16. Then they are asking the 4b square by a square value. Hope so. Let us check once. Okay, I remember like 4b square by a square. Yes, correct. 4b square by a square they are asking. 4 times of b square by a square is nothing but 17 by 4. So that you will get 16. Okay. So 17 by 4 will give us 4.25. Okay, this is the required answer for the given question. So hope you enjoyed the center mass logic, center mass frame. So please, if you have any doubt, watch this conversion. Okay, so this is from center mass idea, and from the center mass idea to we change it to ground frame idea. So if anyone wants to apply the center mass frame idea, so definitely you should know how to switch from center mass frame to ground frame. Then only the questions can be solved in good manner. Okay, so hope you enjoyed the video. For more videos like this, so please like, subscribe and share with your friends also. Even you can share in your Telegram groups and WhatsApp groups also. Okay, so that will be really helpful to the channel. So hope you enjoyed it. We'll meet in the next video. Thank you so much.